I'll be recording this session as well as I'll be posting this in the YouTube channel. That link also will be available for you guys. That links will be getting in from the announcement channel. So, I hope you guys are able to see my screen now. So here to the bottom right corner of your screen, there is an option called activities. So if you click that, there are 4 options. Out of that, you should click polls so that you can let me launch few questions. So that now we'll be able to find the questions. Let me launch first 3 questions. So while we are discussing the question, you can give your answers. Right now, you need once we discuss a particular question, you can give your answers. Okay, first I've launched first 3 questions so that now I'll share my screen. So every day, like every Monday, there will be a live session. So the live session will be from 6 to 7 p.m. So today there was some power connection problem, so I could not start the session exactly at 6 p.m. Okay, so I hope my screen is visible for all. Can someone unmute and tell?
Yes, ma'am.
Thank you. So we'll be solving some practice assignment questions, so which will help you guys to solve the assignment questions from posted in the NPTEL website. So this problem solving questions will be mostly from the practice assignments that you have already in the already available in the website. So I hope this assignment is particularly from the prerequisite assignment question. So this is the first question for this week. As per IS 267, a maximum of dash percentage by mass can be added as performance improvers in plain Portland cement. So this is the question. There are 4 options. What is the maximum percentage of performance improvement can be added to Portland cement? That is the question. So there are 4 options. You can give your answers in polls. If you're not able to understand the question, let me explain. So, see whether you guys able to. Okay, it's nice to see more responses. So, there are around 66 people in the class now, but I could see only 17 votes. Okay, some people have used chat box. Okay, if you're not able to. To the people who joined recently, please mute yourself unless you have a doubt. You can unmute or you can post your query in the chat box. Let me see the chat box often. And to the bottom right corner of your screen, there is an option called activities. If you click that, there are 4 options. Out of that, you should click polls. There are few questions launched. So as we discuss 1 or 2 questions, you can give your answers there. And then or else if you're not able to do that, you can give your answer in chat box. Okay, most of the person have given your answer as 5%. Yeah, that's the right answer. Let me go back to the presentation. So most of you have given the right answer. Yeah, as per IS 269, we can add up to 5% performance improvers. Mostly these days they are using fine limestone powder or fly ash, whichever is possible. They'll add. So now we'll see why we are adding it. So we have a question why we added. So I expect you guys to watch the week 1 content before coming to the live session, so that it will be helpful for you guys to recap whatever sir has taught in the video. Okay, so moving to question 2, which is already launched in polls, you can give your answers. As per IS 269, a maximum of 5% can be added. Okay, why we are adding it? And it's called performance enhancer. Why we add it? What is the purpose of adding that? That is the question 2. Option A is it increases the strength of the concrete. Option B is it increases efficiency, net emission energy emission cost of cement production mill, and option C is it decreases the pollution caused by cement mill, and option D is all of them. So you guys have to find the right answer and give your answer in polls as well as chat box, whichever is possible for you. It's called performance improve, but what performance does it do? That is the question. And if you have gone through the video, then it is very direct. Okay, option B. Fine. So this is the question, and this is the option. Okay, more people have gone for all of the above. Okay, nice. We'll see what is the answer. Okay, we'll see the chat box as well. Oh, my voice is not clear. Okay, let me keep the mic little bit near to me, so you will be able to hear properly. Okay, D. Okay. So overall, option D. You guys have picked option B more. Okay, at least stop the response for question 1. So question 2 be here. Okay. So more people have gone for option D and few people have gone for option D then A, C. Okay, fine. Let's see the explanation for this question. So, what is the purpose of adding this performance enhancer? So, mostly we use finely ground limestone powder and then not fly ash or slag, so which is not calcined. Okay. So what is the problem of like why we don't do calcination of this 5% performance improvement and why we are adding them directly? That is the purpose why we do that. Okay. So the reason is because it reduces the net energy emission, carbon dioxide emission as well. Okay. So generally, let me use the pen option here. So we know that calcium carbonate is one of the raw material that we use in the cement production, which is the major portion of the raw material used for cement manufacturing. So what if we calcine it around 900 degrees Celsius? Okay, what happens now? Can someone unmute and tell? What if we calcine the calcium carbonate, that is limestone at 900 degrees Celsius, what will we get?
Carbon dioxide will be released.
Okay, that is fine. Okay.
Calcium oxide plus carbon dioxide.
Okay, fine. Thank you. So there will be calcium oxide and then okay, so obviously there will be emission of carbon dioxide when we calcine this calcium carbonate. So we are trying to reduce this limestone content from cement manufacturing so that we can reduce the carbon dioxide emission so that it will be helpful. Because cement industry is one of the major industry which is contributing to this carbon dioxide emission. Around 6 to 7% of carbon dioxide is man-made carbon dioxide emission is from the cement production industry. So we're trying to manufacture 1 ton of cement, we more or less generate 1 ton of carbon dioxide. So the main aim is to reduce this carbon dioxide emission. So the correct answer is option B. It's not option D. It's not for increasing the strength of the concrete, or it does not decrease the pollution caused by cement mill. Mainly, the purpose is to increase the efficiency of the cement production. That is the right answer. I hope you guys got it right. Let's move to the next question. I have already launched this question in polls so that you can give your answers in polls. The question 3 is, which of the following materials are not added to the kiln in the manufacturing of ordinary Portland cement, that is OPC? Here, you should not think about what are the raw materials for cement manufacturing. Here the question is very clear. Which of the following materials are not added to the kiln? So all these materials are used for cement manufacturing. But which of the materials are added only to the rotary kiln to burn the material, to calcine the material? Option A is limestone, option B is clay, option C is coal, and option D is gypsum. So you need to find the one which is not added to the kiln. So let me help you guys to a certain extent. So limestone is limestone is nothing but calcium carbonate, is the primary source, and then we also add clay, which is the source of silica as well as alumina, and then coal is nothing but the fuel to burn the material, and gypsum is nothing but which is used as a set controlling agent. Okay, and we also add 5% of performance improver. This is the raw material, but which is added to the kiln matters for this particular question. So I hope you guys got the answer. Let me see what answers you guys have given. Let me check the polls. Okay. More option is coal. Okay. You think that coal is not you added to kiln? So then how will the material will burn? How will you burn the material then? What is the fuel then? You need fuel to burn the material, right? If you only add limestone and clay, how the material will burn? We need something to burn it, right? Okay, let me see the chat box as well. Ma'am, fly ash does not help in strength. Okay, so does not help in strength. Okay, so here you're asking about the last question regarding performance improver, I suppose. See, here what is the main purpose of adding it? The main purpose is to reduce the carbon dioxide emission, which is explained in the lectures very clearly. So, what if we add limestone powder? What if we add some quartz? So here we are not specifically saying the if we add fly ash as a performance improver, will it affect strength or not? No. Here we are mentioning what is the purpose of adding that 5% performance improver. So here the main agenda is to reduce the carbon dioxide emission. So that option will be ruled out. Okay. Option D. C. Okay. Let me check the polls again. Okay. So now let's see the answer for the question, because more than around 30 people have given your answers. I request everyone to give your answer, even it's right or wrong. That doesn't going to affect you anyway. So no one will know who give the answer. So no problem. You can be feel free to give your answers. If you guys are using mobile, then there will be 3 dot in the Google Meet. If you click that, you will find these activities. Okay, if someone is finding it difficult to find activities, I'm saying this option. Okay, let's move to the answer. See, here it's clearly mentioned which is not added to the kiln, because gypsum is added once once the clinker comes out of the kiln, it's sent to the cooling zone. It will be cooled and the clinker will be formed properly. So after that cooling, while grinding only we add gypsum. We don't add gypsum to the kiln to prepare ordinary Portland cement. So the option is gypsum. So everyone is asking, everyone must have felt coal is not required, but coal is required for heating the material. Okay, for burning the material. Okay, now let's move to question 4. This is very direct question, simple question. What is the temperature required for manufacturing of ordinary Portland cement in the kiln? There are 4 options. Let me launch the question in polls. Please be patient. Option A is 1000 degrees Celsius. Option B is 1250 degrees Celsius. Option C is 1500 degrees Celsius. Option D is 1750 degrees Celsius. You can give your answer in polls. Let me end the poll for question 3.
Madam,
Okay.
question is not visible, madam.
Yeah. Now I'll launch the question poll. Just a minute. Yeah, now I've launched. You will be able to see. I'll launch the remaining questions as well. Now it's visible? Yeah, you guys have started giving the answer.
Yes, madam, visible, madam.
Okay. what is the max, like temperature sense, what is the maximum temperature will be required for manufacturing OPC? That is the question. So more options for option C. Okay, let's see. Yeah, let's see option C more. Okay, since the direct question, let me move to the explanation part so that we'll have time to discuss the rest of the questions. So this is the schematic diagram of the rotary kiln, which is from the lecture. So we can see that the maximum temperature, we knew that less from 50 to 100 degrees Celsius itself, the free water will be absorbed moisture will be evaporating, and then by 700 to 800 degrees Celsius, the clay will decompose, and at around 900 degrees Celsius, the limestone will decompose to calcium oxide and carbon dioxide, and then at 1200 degrees Celsius, C2S will be initial formation of C2S will be there, and around 3350 degrees Celsius there will be formation of C3S, and then finally once like but the C3 and C4 air phases will be properly formed only during the cooling zone. Okay, so then what is the maximum temperature? It's nothing but 1500. Okay, so now let me move to question 5. Question 5 is also very direct. So here the question is, alpha C2S is present in which clinker? I hope you guys know what is my modern clinker and what is my aspirant clinker. So where alpha C2S will be present? Either it's in modern or aspirant. Aspirant is with the old OPC clinker. Right now it's not in the practice. Whatever clinker we have is a modern clinker, and then where alpha C2S will be present. Alpha C2 is nothing but a polymorph of C2S phase, dicalcium silicate. It's not pure C2S, and either it's present in both the clinkers or it's not present in any of the clinker. We can give your answer in polls. Let me check your response. Okay, option A, option B. Okay. Okay, fine. Let me see. Let me end the poll for question. Okay, more people have opted for modern clinker. Yeah, and chat box also I could see more option A. Fine. Let me move to the explanation part. So here is the comparison of Portland cement clinker then and now, which is with aspirant clinker and the modern clinker. So we all knew that alpha C2S is not present in aspirant clinker. Only in the modern clinker it's present. Around 10 to 20% will be of alpha C2S in the modern clinker. Now let's move to the next question. So the correct option for question 5 is nothing but alpha C2 is present only in the modern clinker, not in the aspirant clinker. Okay, so moving to question 6, it's similar to question 5. In modern clinker, the LH size is reduced and billet size has increased because why the LH size has reduced and billet size has increased? We all knew from this table that the size of the LH, so the LH size is larger and the billet size is smaller comparatively to the modern clinker, and in the modern clinker LH size will be smaller and billet size will be larger. Why it is done like that? Why it is made like that? If you guys have gone through the lecture, only you'll be able to give this answer. because sir has explained this and it's not given in the slides actually. Unless you watch the videos, you guys will not be able to attempt this question. I've already launched this question in poll so that you guys now should be able to give your answer in polls. If you guys are not able to give your answer in polls, you can type in the chat box. If some people find it reading, so I'll read out the options A to D. Option A is to increase the reactivity of halite, and uniform and complete burning in rotary kiln leads to larger crystal size of halite. Option B, to increase the reactivity of halite, and uniform and complete burning of rotary kiln leads to smaller crystal size of halite. Option C is the modern clinker production process needs slower burning rate, and so halite size is reduced and halite size increased. And option D is both A and C. Someone has unmuted yourself. Please mute. It's disturbing the whole class. Please mute yourself. Okay, let me check the response. Okay, more people have opted for option A, and people have opted for option A and C. Okay, you feel that modern clinker production. Hussain, please mute yourself. Please mute yourself. Yeah. Okay. Someone has opted for both option A and C. Okay. See, let's see option C. The modern clinker production process needs slower burning rate. Do you think so? So the burning rate should not be slower. So option C is not correct. So both option A and C will not work out. Okay, let's see the explanation part now. Actually, I have not added any particular explanation, but we'll see the options here so that we'll see which options is working and which options is not working. So to increase the reactivity of billet, we all knew that halite is more reactive than bilite. Okay, so if we have to increase the reactivity of halite, obviously we have to reduce the size of halite. So the point to increase the reactivity of bilite will not anyway that is not right, and complete burning in the rotary kiln leads to the larger crystal size of billet. That is true because the complete burning of the raw material in the rotary kiln that lead to the formation of larger size of billet crystals. In the older clinkers and all, proper burning is not achieved. So that was one of the issue, and which is the advantage of shifting from vertical kilns to rotary kilns where there is a proper burning, complete burning. And then the modern clinker production process needs slower burning rate. No, that's not true. So that option was the rule. So the right option is nothing but option A. Unless you guys watch the video completely, you'll not be able to understand this fully. So please watch the videos, and I request everyone to watch the videos and come to the live session, or else it will not be helpful for you also. Okay. If someone has any query in between, you can post in the chat box, or else you can unmute yourself and ask, so that we'll have a clarification. If you like after completing the session also, we'll have let me try to wind up the session by 10:45 or 10:50, so sorry 6:50, so that from 6:50 to 7 we can have a clarification session. Okay, so now moving to question 7. Excess free lime in OPC causes. Sorry, I'm not put this question in polls, so give me a minute, I'll post this question in polls.
Where we have to watch the video, ma'am?
From the NPTEL website. The video is there, right? The professor's lecture.
Okay, ma'am.
Yeah. There will be videos, there will be lecture notes, and there will be presentation. So you can watch everything. The whole whatever sir spoke in the class also will be available as a PDF.
And where we have to submit the assignments when we get?
When you go through the assignment, the final step will be submit assignment, right? Once you give all the right answers, you can submit the assignment. So the bottom page of the uh, just a minute. So the bottom page of the assignment also will have submit options. Okay, if you once you click submit, the answers will be taken.
And we have to join with the same link in Monday or Tuesday.
Okay, Monday separate link, Tuesday separate link. Okay,
So
that
that
you will
link
get
is
in the
provided in Gmail.
that you will get from the announcement, as well as that you can find in the announcement tab, as well as you'll get receive as an email, reminder email. But the same link will be used.
Okay, ma'am.
Okay, but for Monday separate link, Tuesday separate link. Okay, please give your answer for question 7. Okay, someone has raised your hand. Okay, fine. Let me go through the chat box. Okay, option C. Previous question answer. Previous question answer is option A. Yeah, thanks for the explanation. Here, Chirantana has given the reason why the heating rate should be more, because billet will be like elite will be formed elite will be converted back to billet if the heating rate is not fast. So the heating rate should be higher, so that the formed elite will be remaining as elite. Okay. C unsoundness. Okay. Fine. First question answer. Okay. So let's discuss this thing later. We'll have a fast go through while. Anyway, I'll upload this PPT, and then this PPT also will be available for you guys post after this meeting as well. We'll give the links for that, and then these questions are taken from the practice assignment questions that is in the website right now. So in the coming weeks, you guys can't expect the practice assignment questions from the website. This time I don't want to take new questions from the video. I for the next weeks and all, I'll take new questions from the video, so that it will be helpful for you when you solve the assignments. Okay, now let's see the explanation part. So how do we measure the excess lime in the produced OPC? Can someone tell me? How do we measure the excess free lime in the OPC cement? Okay, no answers. So generally we have this quality control parameters. The one used to check the excess free lime is lime saturation factor, which is called LSF. Okay, LSF. So we calculate this lime saturation factor. It should be mostly lie in the range of 93 to 98. Mostly for OPC, it lies in the range of 99 to 98%. So if it is 100%, then which means there is presence of free lime in the system. Okay, if it's more than 100%, then it indicates the presence of free lime. And similarly, we have other factors as well, like silica ratio or silica modulus, alumina modulus. But the factor which is used to measure the excess free lime, then it is the lime saturation factor. If it is more than 100%, then it indicates there is presence of free lime. And what is the problem of this free lime? It causes unsoundness. There will be expansion in the cement. If you like, once the cement undergoes hydration, there will be expansion because of this free lime, okay, which is called as unsoundness. So which is nothing but the answer for question 7 is unsoundness of cement. Okay.
Ma'am,
Yeah.
How we identify the practical fields?
Sorry,
How I identify in the practical fields?
practical.
It means I'm working as a site engineer.
Okay,
I'm casting one of the structure.
okay.
So how we identify?
Excess line you're asking, right?
Yes, yes, yes.
Okay. So generally there is a test for this unsoundness of cement. To check for the soundness of cement, there is okay.
Crack development.
Not crack development. Wait, just let me give you the code for the, right now. I can't exactly remember the code for the soundness test.
Yes, ma'am. I already found this check in the leach at nearby method,
Yeah,
and I found a 2%, 2%, 2 or 3%. Actually, it is
up to
done already.
10% it's fine. Up to 10% it's fine.
Uh, but I observed that in one of the cubes, CI cubes,
Yeah,
150 cubes, observed that the excess line observed in the cubes, outer surface.
there is efflorescence.
I don't know, ma'am. I'm asking what this is the excess line or for us.
Can you repeat the
White
question?
patches is called as efflorescence, madam.
Yeah.
White patches observed in the cubes, outer surface
Okay.
of the cubes.
Okay. Okay.
So
Uh,
it's called excess tree line. Can you
it,
be
it can't be only
told?
because of excess line. There are several factors, but
Hmm.
the major thing is if there is excess line, there will be efflorescence. If there is alkalis also, we can find this efflorescence. If the alkali content is higher also, we can find some efflorescence. Hello? Can you follow me?
Actually, in cement, yeah, water.
uh, we don't know like if even if it's in the water or if it's in the or if it's mostly if the cement is bought from a particular brand, obviously they'll control these factors, right? So it's better to check for the external factors. Maybe you can check the curing water.
Mm.
You can check the
Okay.
quality of the water used for curing. Then
Okay. I
everything.
found the quality of I found the quality of water is chloride is around 550.
Oh, okay.
So it can be uh, issue.
Okay, sir, actually, I could not exactly remember what is the limit for chlorides for this curing water. Let me note it down. Let me give this answer. Uh, let me ask the person who's handling the live session tomorrow to give the answer, or else I'll give you answer in the next week. Okay, let me note it down.
Okay.
You're saying the chloride limit is
Uh,
550, right?
my question, madam, is which is कि I observed the cube's outer surface is white patches.
Okay, fine.
It's called a free line or anything else.
If there are excess alkalis, also this can be possible. If the water has some alkalis, then it can be also one of the reason.
Okay, so which type of I suggest a test for water or cubes?
You can test the curing water. You say the curing water
Which
is
type of test conducted?
okay.
Means
You're asking the type of test.
chloride. Uh,
You can check the chemical.
so I can found.
You can use ICP-OES like inductive coupled plasma optical emission spectroscopy. You can do the chemical analysis of the curing water, but it's a
In the
high
chemical
end.
water, many tests are available.
Sir, can we
For
keep this
this
discussion?
purpose,
Like still
how
have
can
three
I
more.
identify?
Sorry, sir. Sorry to interrupt you. Can we discuss this question once I complete all the 10 questions? Is it fine for you?
Okay, no
Okay,
issue,
sir.
no issue.
We'll Paka discuss the question,
No
but
issue, no issue.
yeah, let me finish this question. Still, I have only three more questions. Very simple questions. Yeah, thank you for understanding. Let me move to question 8. So, this is a very direct question. You can give your answer in the chat box. I'm not going to put in the polls. Okay, it'll take time. So, the question 8 is the plane's finest value of OPC typically is in the range of. There are four options: 3 to 5 meters square per kg, 30 to 50, and then 300 to 500, 3000 to 5000 meters square per kg. Please give the right answer in the chat box. Let me check the chat box. guys need to see the question. Okay, let me wait for 1 minute. You just see the question, give your answer in the chat box.
Madam, one second question repeat, madam.
Okay, the question is the Blaine's fineness value for OPC typically is in the range of option A 325 meter square per kg. So the unit is same. Let me repeat the number alone. Option A is 325, option B is 30 to 50, option C is 300 to 500, option D is 3000 to 5000. Unit is meter square per kg for all.
Ma'am, it's 300 to 500 meters square per kg.
Yeah, that's the right answer. So let me see the chat box later. See, let me see what is the response of the class. Now let me move to question 9. So this is a very direct question from the video. Okay. So this schematic, the given schematic is for dry mix process of cement manufacturing. So there are two different processes, right? Dry mix and wet mix. Okay. Let me see what is, when we go for dry mix and wet mix in the next question. But in the current question, the given schematic is for dry mix process. So which step is not followed in wet mix process? Here, first it will be limestone quarrying, then there will be crushing and grinding it, then we will do preheating, then it will be taken to rotary kiln where it will be calcined, the clay will be activated, limestone will be decomposed and it will form C2S followed by C3S. It will be heated up to 1500 degrees Celsius. Then it's
Six.
to 6. Okay, fine. You're saying it's step 6. Okay, let me see what is the answer. So next from rotary kiln it is taken to the cooling session. Okay, cooling stage. So where C3A and C4A phases will be formed in step 5. Then once the clinker is totally formed, it will be stored and then finally it will be taken to grinding along with gypsum. Then it will be taken to then it will be packed in bags or it will be sent to the cement silos. Okay. So this is the process given for dry mix process. Which particular process not followed in the wet mix process? That is the question. Someone told me of step 6. Step 6 is common for all. No, clinker is stored for either if it's dry mix or wet mix process. We store the clinker. No. Then how you are saying?
Gypsum not adding.
No, we'll add gypsum for all the clinkers. It is a set regulator. Without gypsum, so okay. What is the role of gypsum? You know?
Prolongs the
Binding.
initial setting, madam.
Okay, sir. Like someone had told me, gypsum is not added for wet mix process. No, because if gypsum is not present, then there will be flash setting. Immediately, it will form hydrocarbons as a reaction product. So obviously, there will be flash setting. Okay, so that is not followed. We need gypsum for all the either it's wet mix or dry mix. So which particular process not taken for? It's not for wet mixing. So most in the case, the option is step 3 because preheating is not followed generally in wet mixing process because we can say the answer in two ways. One is most of the cement manufacturing industry in India, mostly 80 to 90% or more than 90%, it's dry mix only because dry mix process is more efficient, energy saving process because in wet mix what you don't know. We'll add water while grinding the material, so it will be in a form of paste kind of thing. So that we'll take it to the rotary kiln because preheater what we'll do is while cooling, no, while we cool the clinker once it's formed, that heat will be trapped and it is used as a and trapped and it will be taken for the preheating zone. Okay, where partially the raw materials will be calcined. It will not be completely calcined, but partially it will be calcined. It is used. The heat is reused. So most of the modern cement plants have this feature, but the old cement plants mostly are wet mix process. So there we don't this particular option called preheater. So we don't use this, and also the wet mix clinker will be it will have more moisture content where preheating will not be beneficial also. It may not be beneficial, but the main thing is the wet mix cement manufacturing units are very old where this preheater is not there. So that's why preheating is not followed in the wet mixing process. Okay, and wet mixing requires more energy because we are adding water, then we are grinding it, and then obviously removing again the heat. But the one advantage with wet mixing process is, what is the one main advantage with wet mix process?
Cost efficiency.
No, it's not cost efficient because we need more energy to add water, grind it, and remove the water again. We need more heat and energy, so it can't be cost efficient. Any more answers? We can. I don't think you don't need to feel wrong
Weather
because
conditions.
tell me
Weather conditions.
weather condition.
Yeah, ma'am.
I'm asking the one advantage due to wet mix process. I'm not asking why we go for wet mix process.
Quality of cement is very good
I don't know
compared
what.
to dry process.
Sorry.
Compared to dry mix,
Okay.
quality is good
You're saying the
in wet
quality.
mix. Comparison only.
Okay.
Yes.
So I don't know exactly quality. Maybe quality could be one of the reason. The main thing is there will be uniform composition of the raw meal will be formed. Okay, because since we add water and mix, there will be uniform mix of the raw meal. So that is the one advantage. So that might result in good quality. That I am not so sure. But the one main advantage is a uniform mix of the raw meal will be attained in wet mix. Okay, that might lead to good quality. Okay, so I was explaining something, but I sorry, I got missed out in the middle. Okay, so generally, so what happens is we need more energy to remove the moisture added while wet mixing, so that process is not preferred mostly. And then most of the cement plants in India are constructed of 1980s, so most of the cement plants here is dry mix process. So mostly the raw material will be grind and mixed in the dry form, and the heat from the cooling zone trapped will be used in the preheating zones. So the material will be partially calcined and ready to enter the rotary kiln. So it's more beneficial in terms of energy efficiency and cost as well. Okay, let me move to question 10. So question 10 also you need to type the answer in chat box. So question 10, you have to match both the left and right section. So when we go for wet blending and when we go for dry blending, and what is the role of cyclonic separator and what is the role of pre-calciner? I've already explained what is pre-calciner to a certain extent, which is in the preheater zone. Okay, what is the role of the preheater zone and what is the role of cyclonic separator?
CABD, madam, answer.
Sorry.
CABD.
Okay, let me check. Okay, let's see what is the right answer then. Let me check the chat box now and we'll see the answer. ACBD. Okay. CADB. Okay. Some people have mentioned high strength for wet mixing, I suppose, but okay, no. Wet mixing will not give you uniform, better stem. I don't think so. Like that might not be the right thing. The main purpose is to get a uniform round. Okay, let's see the answer for question 10 because the time is already ending. So the answer is nothing but CADB. So when we go for wet blending means if the moisture content is more than 15 to 20%, then we go for wet blending because at that time, if you have to dry the material naturally outside, then it will take more time. If the moisture content is less than 8%, then we can go for dry blending. And then the role of a cyclonic separator and the preheaters and all for properly mixing the raw materials, we use that. And then in the role of pre-calcin is to remove the moisture as well as carbon dioxide because it will go undergo partial calcination. So obviously it will remove the moisture as well as it will remove the carbon dioxide. Sorry, it will calcium carbonate will be there. No, it will be partially calcined so that it can remove. So it can calcine certain amount of limestone which will be converted into calcium oxide and carbon dioxide. That carbon dioxide will be removed. I hope you guys got it right. Okay, now let's move to let me go to the chat box because some people have posted their questions here. Okay, some people have given carbon. How does calcium carbonate decompose? Fine, thank you. And then if you guys have any note, can you please post in the chat box now? I could not go through the whole chats. I have already told where we can watch the video. Please go to the NPTEL website, log in with your Gmail IDs, and then go to the course page. From that, you can watch the videos. Previous videos. What is my previous videos? The course is running for 2018. The same videos are used, so you can watch the whatever video is present here is the only video you have. You can watch that video. And previous question paper, you have a practice questions. No, that is that you need not need previous questions, but you can use the practice questions actually. It is posted in the this is in the website. Please log in using your Gmail ID, register Gmail ID or any emails you have, and please go through the website. Please you can find the PPTs used for the lectures. You can find the lecture note, whatever transcripts you can find. Whatever sir has discussed in the class is also in the transcript, and then you can see the videos. There will be 4 videos at least for 1 week, 4 to 5 videos. You can watch the videos from there. Okay, thank you. Someone was asking a question, right? Sorry, I forgot your name. Sir, are you still in the call? Who was asking about the site condition thing? Okay, thank you all. The session is done. You can leave the class. Someone was asking some question for. Sorry, I forgot your name. Maybe I didn't note your name. Let me try to find out your find out the answers for your question. In the next class, we'll see.
Ma'am, look, sorry. My name is Rakesh Prajapati.
Okay, Rakesh Vedapati. So your question is why does the white patches in the cube, does it mean only free line or something else? And what test can be done to check the water quality and all, right? I could remember the maybe let me go through the codes and give you the answer in the next meeting. So before leaving, I request everyone to watch the video and come. Please join the session by 6 o'clock so that you'll be able to answer. Mostly you'll have 10 questions for one live session so that it will be helpful for you. Okay, then let me wind up the session now. Thanks for all. Thanks for the patience.
Thank you, ma'am.
Okay,
Thank you, ma'am.
thank you.